Good morning, everyone. Thanks for joining us. I think we've got a few more folks wandering in from the keynote. I'm Neil Bird. I'm Vice President of Federal for a company named Latent AI. And today we have an esteemed panel that wants to share what practical autonomy is available today for our U.S. military. Focusing a little bit on the fleet, but all of our agencies can benefit from what's going on and taking AI to the edge so our operators and our soldiers, sailors, and airmen can actually do the job where they are working. But to introduce the panel, I'd like to introduce Rear Admiral Doug Small, retired U.S. Navy. Dr. Brennan Yamamoto, he is the head of robotics and engineering for Havoc AI, a surface uncrewed vehicle company. And John Gargano, retired Master Chief out of the U.S. Navy, 30 years out of the teams, giving us all a perspective of the Admiralty, industry, and an operator's perspective on how things are happening from AI at the edge. So, sort of set the table for this conversation this morning. Need you to think back about going on almost 2 years ago. So it's the first quarter, 2024. This small country that didn't have a navy is facing a superpower in the Black Sea. And in January, February, and March, they successfully used uncrewed surface vehicles to take out a corvette, a landing ship, and a patrol ship consecutively over 3 months. Kind of unheard of in the history of warfare, at least publicly speaking. When Ukraine did this, it was sending shockwaves through the world. How did they get that advanced technology to take out a superpower's naval vessels and really protect their grain shipping lanes and their economy from being blockaded for what was not the beginning of the war, but ongoing in the war? Then fast forward to just a few months ago, and our Navy is under attack by aerial unmanned vehicles at a unprecedented rate. High volumes of arguably mid to low tech capability with targeting capability improving on the fly as we were being attacked and having to figure out how to fight that off. So what we want to talk about today is how do we continue to face that threat effectively? And how do we change from a platform-centric purchasing organization in the Department of War? We can't continue to purchase the same way we're purchasing things. We can't purchase an aircraft carrier and a submarine the same way that we're going to purchase unmanned vehicles or uncrewed systems. We have to be able to iterate faster, we've got to test faster, and we've got to get products and solutions into our warfighters' hands so we can face down these threats. So to take that table setting, we'll open it up with some questions, and we'll start with you, Admiral Small, and talking about sort of what are you seeing as kind of the gaps of getting from what we have been from completely manned or soldier-driven or sailor-driven capability to autonomous capability? And are there significant gaps in purchasing and doctrine and standard operating procedures and CONOPS?
Yeah, so thank you for the question. The answer is, of course, yes, there are those gaps. If you just what you described, Ukraine sort of creating an unmanned systems entire ecosystem, albeit because they had to, compared to what we have actually fielded and deployed, there's obviously quite a stark difference. Now, we're not currently at war, but as Admiral Kaler said, we want to be able to demonstrate, credible combat-ready capability, so that we don't have to go to war. And certainly unmanned systems are a part of that. There's no doubt about it. It's part of the changing character of war. There's many reasons for that. And hopefully we can flesh out some of the technical reasons and other sort of things, but you kind of hit on this idea of, how we budget, how we talk about a Navy is very platform centric. How many ships are we buying? How many this, how many that? And trying to get to something that is more networked and software driven, like an unmanned systems ecosystem needs to be. That's what we're kind of wrestling through right now. Certainly the replicator effort kind of stepped in and filled some of that gap, but how we go from a very platform centric to more of an unmanned ecosystem is definitely part of the conversation that needs to be had. Thanks.
Thank you, Admiral Spall. So, Brennan, as a provider of these solutions in this space, what kind of challenges are you seeing from sort of traditional ways that the government's been consuming technology like you assemble and sell versus what you think the improvements could be to help get it consumed faster?
Yeah, I think there's currently this philosophy towards singular exotic assets, right, with DoD acquisition, and that needs to change somewhat. I mean, not diametrically change, but we need to start opening our minds to different ways of doing things, right, operationally. I think a spirit of, asset attrition that's going in an operational space, having the ability to not see a theater as sort of black and white, but rather a probabilistic treatment of, understanding what's happening. And that picture is constantly changing, right, as more information comes in, as certain, if you're in an intradable space or you're in a austere sort of contested space, your understanding that common operating picture is not perfect. And there's technical challenges that there's technical things that can be done to improve that picture, but there's also, an operational understanding that it's not very binary. Does the ship exist? Does it not? Right? But rather, what does my fleet look like? How are they operating? And how does that information ultimately make its way back to human operators, which are still essential, but their role in an operation is going to change, right, in the face of robotic assets.
Absolutely. Thank you. So, John, you were an operator for a long time, and we've witnessed a lot of effectiveness from sort of first-person view kind of drone capability, sort of a one-to-one relationship. You have an operator operating a machine to go help speed up the mission. What are some of the challenges that you're seeing with that, and then how do you start scaling that to a one-to-many?
Yep. Thanks for the question, Neil. Definitely challenges there. And, we talk about a tiered autonomy approach. And we don't really have those tiers laid out. Tier 1 is this, tier 2 is this. We're not quite there yet, but you can kind of think about it, along a sliding scale where we're with zero autonomy is, 100% human in the loop. I'm the one flying that drone. I'm picking the target, and if it's a hunter killer type drone, then I'm going to execute that target. Then if you want to start maybe the next tier up, and just came back from a trade show over in Ukraine. Brave One put on the trade show. Hundreds and hundreds of UAV companies and UGV companies were there. And the pace that to see them innovating is really unprecedented. I haven't seen anything like it. And really what they're focused on right now, at least with the drone companies, is that last mile targeting, right? And so we're talking autonomy there. That last mile, I've got a drone up, maybe it didn't detect the target. If I got a human in a loop there that I can say, yep, that's the target I want to go for. Press the button, and from then on, it's autonomous. That is that last mile that they're really focusing on. And one thing that happened there, it was the last day of the show. We were packing up, getting ready to head back to Poland for our flight out of there. And I had a UGV company come up, and he was talking to us about latent AI and what we can provide. And this is just to demonstrate the pace that they're innovating over there. They asked me, they said, hey, can you guys stay back next week? We'll test your technology on our UGV in Lviv over the next week. The following week, we'll have it out on the front lines. And if it works, then we're going into production. So unfortunately, we weren't capable, we weren't ready to do that, but that's just to demonstrate the pace of what they're taking that autonomy, call it tiered or not, and especially for that last mile for an ATR type scenario, that's really what they're looking for. It's difficult, a lot of regulations to get through, a lot of policy, but we're not there yet. But I think that's the goal.
I think another challenge just across the board when you start thinking about doing anything autonomy out at the edge is you're always working in a denied environment. and you really need to be able to fight in a GPS denied environment. So how do you take capability straight down to these devices and actually make that work with the command and control that you're trying to work with, even if it's local? If you have some kind of mesh network that you're working with the group that you're fighting with right where you are, but then passing that information up kind of through what we call the edge continuum, getting it from the cloud to the forward operating base or the mock all the way down to the units that are actually in theater. Thinking about those variables and how much exponentially that adds to the challenge. It's one thing to say, I can go out and build 5,000 drones. Do they have the same operating system? Has everybody been trained on how to fly that particular drone? Is it ubiquitous across unmanned surface vehicles? Are the controls the same? Is our targeting the same? Probably not. So how do we start addressing that at scale simultaneously while we actually physically build them? And we can start in the same order. Admiral Small.
Yeah, I'll just start with one of Admiral Kaler's calls for help was in that regard of how do you provide that sort of battle space awareness with manned and unmanned systems. Obviously, a lot of experimentation with resilient communications utilizing military and commercial communications, things like that. But really what we need to get to is, what is our naval equivalent to the fiber optic spool that the first person view drones have spewed all over the battlefield. So we have to be able to figure out how to operate these things in an extremely denied environment. And there's a whole lot that goes into that. First off is, ask the users and work with them. It's not like every system has to be constantly communicating, streaming data back. Put as much intelligence out there as possible to offload some of the need for that constant communication. Work through the ConOps with the operators and then figure up sort of the resilient communication schemes around there. And there are plenty of commercial companies working in that space to be able to give us multiple options. And that's the other part of it, is just make sure you have more than one option for how you're going to communicate.
Yeah, just to add to that, I think GPS or sat nav denied operation is a very prudent example of it's less ethereal, but we can think of that as this exotic sensing modality that we've been developing and become very reliant on for a very long period of time. And as it turns out, unfortunately, it's rather easy to jam and rather easy to spoof. So it's an important problem, as we've talked about, as your fleet size increases, right? You have all of these different dimensions of complexity that exponentially scale with this problem, and adding, inability to localize myself accurately is a huge challenge, right? And there isn't any one single answer to that question, but I think the answer is that we have to get comfortable with leveraging many different technology sets, right, to help solve that problem. We have to be able to develop autonomy that can operate with a very poor understanding, right, of position. We have to be able to leverage or be agnostic to different sensor modalities that are able to give us maybe incremental or odometric understanding of position, which isn't perfect, but it's better than nothing, right? And be able to start using AI, right? And that's a bit of a loaded term, but more software smarts to understand the environment by looking at it in a similar way that people do, right? And be able to navigate around, in a very smart way, right? That's not reliant on something like GPS, right? But, again, there are commercial companies working in this space, and it's important that we partner, and we build this community of technology that's able to, be interoperable, work together. And, there's some antithetical competition, right? That's, loaded in that. And that's where the government needs to step in and, understand that, be very smart about setting requirements when contracting to contractors and say, these are the technologies that we need you to be able to ingest, right? And that requires that our government gets smart about or become, our S&T advisors become very knowledgeable about what technologies can work together, and that companies are developing softwares that are interoperable with each other and not, built with this high-walled garden.
Yeah, I think, Brendan, you mentioned, the GPS denied space, and that's really one area where, as autonomy improves and increases, it's going to help out quite a bit. And I really kind of look at autonomy, for two main goals where it's going to help us out. Number one is to decrease that cognitive load on the operator or on the technician. Let's let AI handle a lot of that so that I can move on and work on other tasks. So decreasing that cognitive load. And number two, I think, is also reducing that potential of human error. Now, of course, there's going to be error in AI models, and that'll get better over time. But decreasing that human error, as I can let AI step up and take more of that autonomous role. Those are the two main areas that I see where autonomy is really going to help us out. And again, with the GPS denied environments, another one, a more difficult challenge, I think, but there are quite a few companies that are working on that.
I think it's a really good point, because if you think taking complexity out of, let's call it code, it's easy for folks out of the valley to say, hey, this is software. It can do anything. We can code it to do anything that you want. But when you're the operator and you're at the edge, you're bouncing around in some vehicle with gloves on, and you got to punch something on an ATAC device and actually make it work. How much are we actually providing you, we industry that are creating code, to make it usable? To Admiral Small's point, we need to be embedded with operators while we build this stuff to make sure that it's usable for all of you. Because if we don't, we're going to miss that mark by a mile. What we think is simple and what we think is, hey, this is AI for the non-AI professional, still might not be simple enough, because it may not work with what you work with on a daily basis. So with that, leading into the importance of kind of public-private partnerships, would love to hear some examples of what all three of you have seen of where public-private partnerships are really working and where there's been some challenges. Pretty sure every panel you're going to talk to this week is going to talk about the danger of the primes and the danger of the new primes. And we can't get locked into such a, call it, proprietary system. We've got to be more standards-based and interoperable. But where can that public-private relationship really lead in handling the speeding up of things like procurement, making it easier to use for operators?
I'll start again, just because that seems to be the flow here.
Good order.
I'll say that the first thing is, when I started in Overmatch, some of the discussion that we had, we thought there was always very military specific problems to be solved. Even with things like Edge AI, we just assumed that was a military problem, and that where would we find a commercial company that's interested in that? And in every single area of military utility where there's been a hard problem to solve, we have found companies that are working on that, either dual use, VC backed, whatever it is, sort of, whether it's defense tech, traditional defense. We have found companies that are working to solve those problems. That's everything from Edge AI, as you know, how to move data parsed around, extremely disparate battle space, swarm technologies. We have whole companies that are building things based on swarm technologies. So I think that's the first thing, especially for any government program managers out there, is there are, no kidding, commercial companies out there that are solving problems that are very similar to the problems that you have and are looking to do business with the government. So I'll just kind of leave it at that.
Yeah, I won't pretend to understand how to tell the government how to do work, but one of the things that we talked about is that we touched on that I do think is really, really important is testing. Getting out in an operational environment, getting technology out there with operators, with warfighters, and understanding what the problems are. Right? There's scientists and engineers, nerdy people like me. We pretend to understand what we think the problem sets are, but we have no idea, right? And we're not going to understand that until we go out, get assets into the field, get them in operationally relevant environments, and test them. And we have to be willing to go out and fail. And I think that's one of the things that separates. I'm biased, right? But smaller startups, who can do things agile, are willing to go out and fail, versus the big primes don't quite have that flexibility, right? And just because of the nature of, and I have a lot of respect for the work that they do, but the nature of how they do work and the cost of their assets, for them to understand really what the edge of the performance envelope is much more difficult than it is for a startup who's willing to go out and break a bunch of stuff, right? And that iteration process is what lets smaller, more lean groups learn more quickly. And I think that's a huge part of the unmanned and robotic enterprise, right? But yeah, it's a huge piece, right? So I think the government needs to be able to promote small companies to go out and fail, and not have that be kind of a mark against them, in their portfolio.
Yeah, I think just going back to that Ukraine example, right? Again, there were hundreds of drone and UGV companies there. A lot of these drone companies, you look at them and they're put together with duct tape, and that's the state they're in. They're at war right now. Whenever it ends, probably maybe 10% of those companies are going to survive, right? But there were hundreds of companies there, and just that pace of within 2 weeks they would have had us in production on the field if we could have proven that our technology worked. That's a type of partnership I think goes a long ways, but it's difficult. They were forced to be in that scenario. We're not quite there yet, but if we can even bridge that gap a little bit, I think that would help out tremendously as far as getting stuff tested and fielded as soon as possible. We go to a lot of testing events, with SOCOM and with MPS out of GIFIX, and it's close. It's getting there, but we still running into that that problem of, all right, well, we tested it, it works, we like it, but there's still that process of going into production. Ukraine they've got to figure it out right now. They have to. It'd be nice to kind of bridge that gap a little bit if we could.
So testing and evaluation historically has been to mitigate risk. And it makes a lot of sense when you're building a full platform. If I'm building a Virginia-class submarine with life support systems, it cannot fail. We'll kill our sailors. So I get the test and evaluation for that. But the adversity to testing risk in software, which may or may not be in the line of human life right off the bat, is really important to look at. So how do we start balancing one size doesn't fit all from a test and evaluation standpoint? So can we create ConOps or a testing capability to test smaller scale software driven things versus in a huge platform faster, without, as Brennan said, kind of putting a black mark against the vendor because they failed, and they failed fast. And they failed fast because we've got to learn, and we've got to iterate, and we've got to change that code literally on the fly. And how about this? How about being able to change that AI model physically at the edge? I don't have to send it back to headquarters and wait for my programmers to retune it and make it work. We can make it help you make it work right at the edge and have operators tune that. So as we reframe test and evaluation, any thoughts or wisdom on how you'd like to see T&E change, or how it might be better to prototype faster?
Sure. Yeah. I think, persistent testing is really essential for robotic assets, right? We need large data sets, right? And that can mean a lot of different things. I'm talking very generically, but we need hours on the water or hours in the air, right? Or hours on land, whatever that happens to look like. And I think another big piece, again, is partnership and community, right? Getting different assets, developed by different groups, whether it's private, different companies, or, warfare centers or research groups, right? Within government, right? We have right now all of these decentralized efforts, which ultimately kind of looks like negative work, right? At a big picture, we have a lot of people redeveloping stuff that's already been done. And that needs to happen inevitably a little bit, but I think if we start doing these joint exercises where we get different groups to actually, the government can put some money down to get groups to work together. I think that will be, really expedite progress.
Yeah, and I'd say, there's, from an acquisition perspective, there's test and evaluation, big time. I'm going out and bringing a new capability. I got to make sure and then there's sort of the test and evaluation of the iterative. How do you get product? Start with a minimum viable capability, and then how do you get that to something that's ready to be released? And for that, I always like the sort of that proving ground concept that, whether the mission autonomy to the replicator proving ground concept, where companies can come and bring their stuff and work with operators and iteratively improve everything from C2 to the autonomy algorithms on the vehicles, and do it in real time and have failures and be able to fix it. But it's not something that's being run for score. It's actually a part of the overall development process that gets you, further along. So that, to me, that's kind of the archetype of what you want to get to with something like this. And just like any software-driven enterprise, you really need that iterative, with operators, ability to fail, iterate, and improve very, very quickly.
Yeah, so I just retired out of SOCOM this past April, so still definitely new at all this. But a plug for the Naval Postgraduate School's JIFIX, Joint Interagency Field Experimentation. They hold this exercise once a quarter. We participated last quarter. They have the next one's going on next week up in Monterey, Camp Roberts. And it's exactly what they're doing. They're accelerating testing and experimentation in the field with operators. It's a week long. We're going to try to go back at least every other quarter, I think. But they tell you from day one, this is not a demo. Bring your engineers, and you're coming out here to fail. They want you to fail at whatever you're experimenting in to kind of push that envelope. Phenomenal exercise, and I think, again, being new at this, that's just one of, I'm sure many that are out there. It's the one that I've seen, and I would highly recommend if there's any, companies out here or integrators that want to go out there and take a look at it. It's once a quarter. The one we did, there were like, I think 65 different companies were there experimenting on their tech, and hugely beneficial. So highly recommend it if you guys have a chance to take a look at it.
If I could just, and another plug too, as Admiral Kaler talked about, the integrated battle problems, that for him, that's the place where people should be showing up with their wares and demonstrating, helping rehearse and demonstrate capabilities. Take your lumps, go fix it, come back next time. It's a continuing series of projects where they demonstrate, in particular, unmanned capabilities.
So we're at TechNet, technology show supporting our warfighters. There's a lot of great technology sitting out here on the floor. We go on sales calls all the time, and we kind of learn about the most elegant solutions being cobbled together. I'd like the panel to share some of the more interesting solutions that they're seeing that are coming together that are ready right now, today. We're not talking about the future or 10 years from now. We're talking about deployable kinds of technologies that the fleet could be adopting, or name the military could be adopting today. And it's not going to be a commercial for our own companies. I'm just talking about in general, what are these solutions that are coming together, particularly around working at the edge?
Sure, I'll start. One thought I also just, on the previous question, sorry, going back, is standards as well. We sort of missed that one, yeah. TAC, UMA, these are very important, right? The government sort of forcing vendors, and we'll, through gnashing teeth, okay, well, but it's really important, right, to keep systems interoperable. But on the question, sorry, of technology, I think what comes to mind is, with unmanned systems, we tend to think very domain specific. Havoc, where I'm from, we largely focus in the surface domain, and we have groups working underwater. But operationally, you want to be crossing those domains, right? You're going to have air assets, you're going to have surface assets, you're going to have underwater assets. You have terrestrial ground assets.
Space. Don't forget space.
And space. Yeah. So I think that's a big piece that we need to sort of evolve and start thinking, speaking of thinking bigger, under start keeping that problem at least in our neural net, right? Of, we're the diversity of our swarms, right? Not just in different vehicle types, but also vehicles operating in different domains, and vehicles operating in different domains have very different operational challenges, right? Underwater, classically, communications is challenging. At the surface, you have surface effects. In the air, you have endurance, right? So, can we leverage the the strengths and weaknesses of each domain, right, to sort of complement each other, right? These foundational problems in robotics, I think, are pretty important.
I would just say, in terms of technologies that are, sort of ready to be adopted today, I'd say artificial intelligence would be one. As somebody still in government acquisition told me, the apathy is real. And for anybody who's ever used things like Copilot or Notebook LM or any of the free things out there, there is a huge gap between what is actually available and what we're actually using inside government networks. So I think that's one area where there is just a lot of work and that's just sort of, I'll say, back office type functions. But even machine vision, is that a ship or not a ship? Is that a tank or a truck or this? Those models are they're probably being used right now. But there's a gap between what's available and how do we adopt them. And I think that's part of what we're trying to discuss here is how do you take those types of technologies that exist and build them into a military capability that can then be deployed. But yeah, in general, artificial intelligence, we're way behind.
Yeah, and I think kind of building on that, go out and walk around the show floor and find those companies that are not only working on AI, but also the autonomy piece, right? That's what this panel is about, is autonomy. Back to your question, we're not quite there yet, but that's what we're building towards. The AI models, they are there, but that autonomy piece, that's where the real work is being done. And again, back to Ukraine, that's what they're doing over there. Mostly because they have to. They don't have a choice. They have to adapt quickly to overcome what they're dealing with. But I'd say for this trade show specifically, go out and try to find those companies that are working on autonomy. Yeah, that's where I'd go.
So we think a lot about, the exquisiteness of our sensors, and can we put more inference on our sensors so we can communicate back to whoever's collecting that information so we can take action on it. But I think we're having an imagination gap on what else could be a sensor. I mean, when we think about wearables, we're thinking about, can we take blood pressure and respiratory and things like that? But could we put compute that's wearable, that's not going to burn up our operators, but actually give them GPU capability to do things like handheld targeting out where I'm operating? Or can I do translation? I don't have to have a translator in tow anymore. These are the kinds of solutions that are available right now that can be deployed and are able to be consumed. But to Admiral Small's point, apathy is real. It is not at the tippy top of, it's not Palantir, it's not Maven. I can't look at it. I can't look at this whole stack of technology that's being thrown on me because I've got to go do these big buys. And that is not completely wrong. You've got to do those buys. You've got to get plugged into the intelligence apparatus, but you can't leave everything else behind at the same time while you're trying to investigate those. So for this to really count as continuing education, we would like some audience participation. And I'm hoping that you brought some questions, or we've inspired some questions from the audience. And either you can use your outside really good projection voice, or I can walk around with a microphone and have you speak. And I'll repeat the question when we hear it up here. Oh, he has a microphone.
Testing. Do you find acquisition ATO to be useful in your rapid prototyping funding for projects? That's what,
Did you say ATO?
OTA,
Oh,
other
O-
transactional authority.
Yeah, I think yeah, there's been a lot of use of OTAs and CSOs. There's been a lot of creativity, I think, on the acquisition side in terms of tools that are available to be used. Some organizations identify closer to certain tools than others. Not everybody has the imagination of using, other than federal acquisition and regulation based contracts, but they are absolutely available. And I think, kind of to the earlier point, there's a lot of commercial companies out there that have a lot of capability that can solve military problems, but they're not set up to deal with FAR-based contracting. So, rather than try to teach them the ins and outs of the uniform contract format, we ought to figure out how to come to some other type of agreement. And there are ways of doing that. Just, again, unless you're part of DIU or maybe some of the more forward-leaning program executive offices, you really need people to kind of figure out what is the right tool for that business arrangement.
I'll take a counterpunch to that. From an industry perspective, we submit to, as a small business, a bunch of SIBRs, a bunch of DIU kind of proposals that are out there. And we don't mind doing that work. We learn a lot from doing that. But when you get turned down and you don't get any feedback about why you weren't selected, you're going to make industry not want to do that anymore. And that's got to be a feedback loop that we've got to start to close, because it's not that industry's out there waiting to jump on a protest. We know that DIU-led things are not protestable, but we need to learn what the gap was. Why didn't we get selected? And that would be super helpful to make all boats rise on the same tide if we could get a better communication loop. And I get it. DIU reviewers can't respond to 300 people necessarily of all the RFPs that they got, but we got to have some kind of feedback. Yes, sir.
They have consortiums for industry, which you become a member, and then you compete with the prototype white papers versus the full-blown proposal.
We do. More of that would be helpful. Other questions? There's a mic right beside you.
That was easy, thanks. First of all, that was great. I really enjoyed that. John, I was curious about the story you told about the UGV company that you were talking to in Ukraine who wanted to integrate your tech and have it in the field in 2 weeks. And you said that we weren't ready to do that. And I'm just curious, I mean, here you are, cutting edge, agile, company. I would love to hear more about that story.
Yeah, I would say, and I can defer to Neil on this one, but I think we weren't ready to do that because, we're a small business. It was myself and our head of partnerships were over there attending this trade show. And we had a booth set up there, and we were, demoing our technology. We weren't ready to surge folks out from our headquarters in Princeton, New Jersey, to get on the ground in Ukraine that very following week and start testing. Now, is this something we're looking into? Absolutely, yes, it is. Because they were ready. They were ready for us. We just weren't ready to surge. Just, I think, where we are as a company, we weren't quite ready to do that quite yet. I don't know.
Had we sent an engineer with them, maybe, but that still would have been a little bit of a stretch. That said, they want to move that fast, and they're looking for partners that can absolutely move that fast. So we are certainly looking at how to flex and be able to accommodate those kinds of requests.
Yeah, it was literally, test next week in Lviv. The following week, we'll have you out on the front lines, and if we like you, you're in. That's how fast they were moving. Again, because they need to, right? I don't think we can move quite that fast here, but let's try to bridge that gap for sure.
Okay. Hey, good morning. My name's Nate Bell, retired Navy LDO type with AT&T now. Retired out of NIWC PAC, so I've been watching trends in the fleet for quite some time. Again, with AT&T, I'm specifically interested in 5G at sea, and that. So I understand the denied environment and everything that goes along with that, but I also understand the ecosystem, the mesh, the thing. So is 5G at sea, I haven't seen the Navy really adopting that as quickly as I would think they would, especially coming out. I was an IP officer, and we didn't even talk 5G at sea 4 years ago, really, when I was in uniform. So is that part of this consideration for the autonomy, the ecosystem, the backhaul, even private cellular network, that sort of thing? I'd be interested.
Yes.
I knew he was going to say that.
Yeah.
No, I mean, it's well, like I said earlier, having multiple options available for how to move information around is one of the kind of pillars of resilience, and certainly 5G needs to be a part of that. Now, I don't know that how far along we've gotten with 5G at sea, but I know there's been some experimentation, and that there are companies here that have actually been working on that. Right. So, yes.
I think part of the challenge is integrating. I've got to put X number of antennas on my system, and I have to get that plugged in and get that approved to be ATO'd. And that's been the long pole in the tent. It's not that nobody wants to do it. It's trying to figure out the standard of how to speed it up to get it integrated into my existing infrastructure. Yes, ma'am.
Thanks. Good morning.
Morning.
So specifically for autonomy at sea, I'm very interested in where people think we need to be concentrating. What are the problems that we really need to be focusing on at sea?
Well, so I'll just, Admiral Paparo has made no, he's basically said he wants to create a hellscape, right, in certain regions of the world, right? So that's going to need something that needs some robotic autonomous behaviors to be able to create that hellscape. I'll just say that's one example. He's also said that basically we should be substituting machines where humans have typically done things like mine clearance and other, so mine warfare would be another area where there's been leadership guidance to make sure that we're delivering systems with robotic autonomous behaviors to be able to handle those things so that humans don't have to.
Yeah, I'm not directly answering your question, right? You're asking for what's the problem set for operating at sea, and that's challenging to answer. I can answer a little bit of what the solution set looks like, right? And that's fielding larger numbers of attritable assets, right? And that blue water operations becomes an issue, right? So communications is a huge problem. And communications as your fleet scales up, right, to try and replace what a single exotic asset could do, but replacing that with a fleet of assets, right? So there's logistics is another challenge that I think often gets forgot when you're talking about large numbers of lower cost assets. Right now, what is your refueling or rebattering, right, or however your solution is powered and how it communicates. Right? How are they maintained out at sea for extended periods? Virtually no one is thinking about this right now, and that's just because we're not quite there yet as an industry. But these are emerging problems that are going to come out of operating in the blue water for extended periods over long distance autonomously. There's a lot of challenges that we haven't really been tackling yet, but there are a few companies at the edge that are looking at this.
If you think about how they were even testing in Sydney the Mark 18 fish to go hunt mines, right? They were taking 6 to 9 months to try to get an AI model physically on the fish itself so it could do inference right where it was locally. And then they had to drive that down to get multiple models on in weeks instead of months. So part of it's speed and scale. And part of it is not combat. How do we do standard operating procedures? The data scientist at sea, how do I do that predictive maintenance on systems just to help sailors answer the question of, this is making a funny sound. What do I do about that? And can they query a system to get help with that without having to be an absolute specialist in it? Yes, sir.
Hello. So a topic that Dr. Yamamoto brought up earlier, you said that we need more of a global solution. not to be specific to a platformer or to a specific area. However, also in this talk, we've talked, Admiral Small and Dr. Yamamoto both spoke about the need for specific AI models, AI platforms, autonomous vehicles to be able to perform the mission. So I'd ask, can you talk a little bit more in this area because as you go forward, you find that we need specifics. Submarines have a specific job, a specific service ships, etc. Our aircraft. How do you look to leverage and scale the autonomy within to be global but yet specific? If you could speak a little more to that.
Yeah, I agree. There's a dichotomy there. No doubt about it. There's interoperability, I think, is a solution, right? So in a perfect world, every company would talk the exact same language and use the same software, but that's just not realistic, right? But I think the general non-technical answer to that question is start with the low-hanging fruit, right? If maybe you don't all have to use the exact same software, but if you're willing to make what you've done available, either as like a warfare center, a research group, or private company, make that available for other people to use. And if you're a budding company, make sure you do your homework and understand, what assets exist, what partnerships can you forge before you go out and just start building your own models, right? I think just sitting here and having this conversation, right? Some sort of vision model that can recognize war-fighting vehicles and vessels, right? And what friendlies look like and what targets look like. Those are data sets that we could be building now, and I don't think any private company necessarily has access to that, but that's, a service that could be done for the entire community. But standards and APIs, right, are the low-hanging fruit answer to that question, right? Is you, of course, can still build in a vacuum, but understand that if the government is going to adopt your technology, it needs to be able to play well with others. Like, that's just inevitable.
Just kind of continuing on that theme, one global abstraction would be the architecture. So Brennan mentioned earlier the unmanned autonomy architecture. So having an architecture that has enough, enough boxes, right, so that if a company has an autonomy algorithm that works, whether it's an airplane or an undersea or a surf, then that algorithm could be utilized in that architecture no matter what the vehicle is. Maybe the sensor has a different, algorithm for is that a ship or a submarine or whatever, but maybe the autonomous part could be more universal. But I think that idea of abstracting the problem through an architecture using best commercial practices like APIs instead of setting rigid standards between how things work would be one example of a global start of a solution set to some specific problems.
And just one last thing to add to what Brendan said, he brought up the data sets. That's really the long pole that we're finding is getting access to that data, because to get to autonomy, you've got to have an efficient and functioning AI model first. For that model to work well, it's got to be trained on relevant data. So getting access to those data sets is key, and if we can figure out that piece, that will go a long ways towards going down the road to autonomy.
Anyways,
You're good.
So I know we talked a little bit about getting those data sets. Would it be easier to get them if we cut out a lot of the red tape and work directly with the end user for those thousands of hours that we need? And then also you can figure out what those people need exactly instead of just going through the grapevine?
Yeah.
Yes.
Cutting the red tape. Absolutely.
I have a solution for that.
That's I don't have the solution. Again, back to Ukraine. The red tape did not exist there, right? But because that's just that's where they were at. That's what they needed to do. Cutting that red tape out, 100% yes. Getting access to those data sets, that would help tremendously. How do we do it? I'm not sure.
There was a recent paper written. I can't remember what organization put it out, but it was basically create this sort of a marketplace where the government can provide government data, and companies can subscribe to that data, work on their models, and then publish them back to something of a repository. Whether they get used or not, you at least fire up the imagination of how can I train AI models on no kidding government data to get around some of the problems that these guys have said. So
There's one thing that the Army's starting to set up innovation cells all across the U.S. and Hawaii included. So if we need those thousands of hours, I have several hundred troops at my disposal that I can use for that R&D testing. All we need to do is just communicate back and forth, say, hey, I have this product, I think it'll work in this environment, and then whatever unit's going out to the field, send a tech with them, they can do that testing, they can get those hours that you need in a real world actual environment, and then we can take that back, figure out what it is Private Snuffy broke, how do we fix it, and then we can make a more robust, more intelligent system as well. What I'll encourage is for everybody in the room, if you guys need to, come find me. I'll be walking around. I work for the Engineer Pacific Innovation Cell. We can get you linked in with the Army Innovation Network, kind of like Admiral, like you said, that depository of people, and we can get that testing further on. So, thank you.
I think that's great. We're not hearing enough of that. I mean, it's been go to the software factories. You're still not getting the real data. They're using synthetic data to even train those models. So unless you're embedded and you've got people that are cleared to the right level to be able to look at that data to actually work with the operators side by side, there's a gap. So we're making some assumptions. And it's just like the rules of physics of combat are still there. You're going to build something really cool in the lab, and as soon as it makes contact, it's going to break. So how do we fix that on the fly where we are to make sure that we can get it tuned up and working at the edge is also something we got to be thinking about. Other questions? Yes, sir.
Good morning, gentlemen. Thank you so much for your time. Great talk. The question I had was more within the scope of robotics engineering. Like, how exactly do robots out there in the wild, once they are within a contested environment and lose GPS communication, how do they maintain that situational awareness? Are they crunching into like big data sets? Are they using optical sensors? Are they using proximity sensors? Like, what's actually happening to maintain that situational awareness?
I can't speak for every technology that exists because I'm certainly not aware, right? But it's a combination of good software, but there are sensing modalities that are capable of localizing without GPS, right? So celestial navigation exists, and that does work during the day. It doesn't work very well when there's clouds. That's a solution, and there are techniques for localizing with some a priori knowledge of the operational environment, right? So if you have some understanding of what the environment looks like, you have, and I'm speaking very, very generically, right? There are different specific sensing types that can be leveraged for this technique, right? But you have the ability to localize, not necessarily globally on planet Earth, but I can place myself within a circle in this local operating environment. Additionally, when you have a swarm of robots, right, that can localize off of each other, some of your error is bounded, and you might not know globally where your swarm is very well, but you can, again, operate in a limited environment, similar to how you would as a human, right? And that's really a combination of really well-tested and really well-refined software and, smart leveraging of sort of, not necessarily low cost, but smart leveraging of different sensing types. The odometric, borrowing from the underwater community, right? Dead reckoning is a term, people recognize, right? Where I don't know exactly where I am, but I can bound myself within some circle, right? And as time elapses, that error grows, but I still have some understanding of, where I am in space. So we have to start getting comfortable with these hard questions, and we're not quite there yet.
Yeah, I think it also comes down to, when you're talking that type of scenario of robotics out on the edge, what type of compute is available to you, right? Is it going to be enough to do what you need to do? Or do these models need to be optimized and quantized so that they are able to run on whatever compute is available? You're talking low power environments here. So what is available to you on whatever platform it is? Are those models capable to run on that, or do they need to be optimized? So that's another piece to take into consideration.
I think your question brings up a bigger point too, and sorry, go ahead and sit down. But this idea of having each vehicle have to know exactly where it is on the globe, right? In an RPV type scenario where the humans are controlling every single vehicle, that's probably what you would need. If they're acting on their own, it's probably more important that they know where each is relative to itself as well as its target, right? And so it's more of a relative problem than an absolute one. And so that's where some of the swarming type technologies can be a little bit more forgiving in those types of environments. But it's also why, when we talk about autonomous vehicles and moving as much intelligence as possible to the edge, because we need more vehicles than we have humans to control them, and they have to be able to operate in that type of environment.
Yeah, and I think most people, this audience understands this, but it's worth being said, right? If you want to leverage EW, like jam a singular exotic asset, that's a lot easier to do than jamming a swarm that's spans many nautical miles, right? So there's another complementary, not even technology, but just complementary leveraging of physics, right, in that problem.
And ConOp, and those are the types of things that you work out when you're working with operators, right? How often do I need to get a picture from the edge? All those things can be worked out to figure out how to operate in that environment.
Part of my nervousness, I'm kind of awkward out here. Very new to AI. I'm very glad you guys are here speaking on this. I'm glad I'm able to listen to you guys. Question on AI. Would we be able to, say, put drones in a position to where they're able to receive information? Say they don't have any mission sets. Now, place them somewhere we know they're going to be, and we use a fixed wing to drop that mission set to them. So then they could autonomously operate from there. Would that be a capability that we're working on, or is that something already in place?
It's a great question. We are working on it.
Thank you.
Yep, absolutely. I think a more primitive version of that same ConOp, right, is if you have an asset out in the field that's disconnected, but its mission was to collect some large data set, right? You can send the UAS over to backhaul that information physically, right? So that will come in the nearby vicinity, backhaul that information locally, and then physically cart it back. That's a simpler ConOp, but exact same idea, right? So there are definitely groups working on that sort of thing.
Thank you, guys.
I think you'll see, even here at the show, there are drone vendors that are thinking about the mothership and baby drones being dropped from that, so getting commands from that. There's also this notion of daisy chaining them. So you could have loitering drones acting as your communication conduit in a denied environment because they can communicate with each other, and you can get it back to the vehicle or back to where you're operating from and say, go do this while I focus on whatever piece of the mission I'm working on. Great questions. Well, we are at time, but I'll take another question if you have one. Otherwise, if you want your continuing education credit, there is a stand at the back that has a scanner on it, and you just scan your badge, and you will get signed up for your continuing education credit. But hopefully you found this panel intriguing enough to spark some imagination. That was really the goal here from our perspective. We will all be hanging out here for a few minutes after if you want to do one-on-one questions, but thanks for your time and have a great TechNet, everybody.